Now that we have our setup complete, it's time to create some tool paths by adding some milling operations. In the CAM tool set, we can see that we've got 2D milling operations and 3D milling operations. For this type of a shape, which is sort of what we would call like a 2.5D shape, it's technically 3D, but all of the components are really just like 2D paths at different depths. So this falls in the 2D category, so we'll be using those sets. If we had a more complicated object, maybe that has some curved surfaces, or I guess like triangular areas, we would use 3D milling instead. Now, there are sort of 4 main options in the 2D milling category. The face option we're not going to use a lot with our CNC router. This, I think, applies more to if you're working with something that can cut metal. And the facing operation just takes a shallow bit of stock away from the top to sort of like smooth out the rough material. Now we'll be working mostly with wood, which already kind of has a pretty smooth top, so we won't need to do any facing operations. The contour operation cuts out outlines, basically. So that's a useful thing when we're trying to cut maybe the outline of this shape. And then we've got 2D adaptive and 2D pocket, which can be used to deal with sort of other internal features. The 2D adaptive is a very flexible feature, and that's what we're going to start with. If I click on 2D adaptive, it's going to jump me into a new CAM set of tabs. Now actually all of these operations feature the same set of tabs, which is pretty handy because once we've done this a little bit, it won't matter which operation we're doing. We'll kind of like have a familiarity with what some of the different features are that we need to modify. It's in some ways it's sort of scary because there are a lot of different things going on here. In fact, like as we click on any of these things, it adds more I guess options that we need to fill in, but as it turns out, we don't actually have to do a whole lot of them. So after doing just a few, I felt like this was not hard at all, actually. We do always need to set up a tool. So this first tab is where we're telling it what kind of spindle and what kind of milling bit we're using, different important values like how fast are we spinning it, how fast are we dropping it down, and those sorts of things. Now, so if we click on this tool button, it's going to bring us to the tool menu. I just have to flip it over here, where we can choose a tool that we're going to use. Now if I just click on one of these folders, there's a whole bunch of tools in here, and these are lined up with some different standard bits that certain machines will have. As it turns out, none of these are exactly what we have. So, but what we can do is we can actually import a library of our particular tools, which is really handy. So what we need to do to go to that is to choose My Libraries and click New Library, and I'm going to call this Carve Tools. I'm going to right click on this library and say Import Tools from Library. Now I have a file sitting here. It's actually called Xcarve Tools, and this is a library that somebody's put together. The Xcarve is another CNC router that's made by the same company and uses the same set of bits. So if we choose this HSM library, right, and we're using Inventor HSM, if we hit open, we can see that it's now populated this library with a bunch of tools. And something that's kind of handy for us is they also have their color coding system, right? Each of the milling bits that we use with our router has like a plastic cylinder on it that's color coded. So I've been using this 2 flute straight end mill 1/8 inch bit quite a bit for my test cuts, and it has the black marker on it. So this is the one that we're going to use here. Now as it turns out, if we look at some of the settings here, they're not exactly right. Now my goal is to go through and update this library so that when you have it, we've got one that's accurate. What I found is that this spindle speed is actually just a little bit too fast. For the Carve, which is a different CNC router, we have a slightly slower spindle rate. So if we right click and edit, this would just be one that you can double check. I should have changed it on your file already, but if it's not, let's look at this feed and speed palette, and we should change the spindle speed to 12,000 RPMs. Our feed rate should be 1016, and our plunge rate, this one's actually drastically different. The Xcarve can be much more aggressive in basically how much material it takes at one time. So that this would be like on a new layer of carving, how far do we go down? And we want to have a much slower rate than that. We want to use 304 as a feed rate. So if we make those 3 changes and hit OK, we'll have an updated one. And we can see that if it has the 12,000, that's going to give us a clue that this one has been updated to match our carve settings. So at this point, I've selected that black one that we've updated. I'm going to hit select, and it's gonna say, are you sure with changing the tool library? You can't press undo afterwards. And we're going to say yes, we're okay with that because we know that the settings are correct now. Okay, so we've set the tool. The second thing we need to do is to tell it the geometry. What are we going to remove? Now the adaptive clearing, it tries to like clear a bunch of area around or inside of some sort of feature. So what we can do for this one is we can select these 2 channels. I'm going to click on both of those. Say that my first toolpath is just going to deal with carving out those rectangular channels. Okay, and in terms of the geometry tab, that's all I probably ever have to do, is just choose the geometry we want to do. When we switch to the third one, this is setting some different heights: the clearance height, the retract height, the top height, and the bottom height. And if we rotate, we can see each of these different heights. And basically, this is like as the tool is moving around, it will like retract to a certain height, or if it's moving somewhere, it will go up to what they call the clearance height is, so that it can move without hopefully bumping into anything else. And for the most part, if we're working with rectangular flat stock, the default should be fine. So I like to take just a quick look and make sure that these things make sense, right? That the retract and the clearance height are like above and not possibly going to bump into anything. Then we're probably good. The fourth tab, this is where we're defining sort of the number of passes it's going to take. This is there's sort of 2 key ones here for us. One is stock to leave, and what this means is like don't cut the whole thing. And that would be if we wanted to come back and finish it more carefully. We can use what they call finishing passes. But in this case, I think this is such a simple feature, we don't need to come back and do a smoothing pass. It's just a rectangle. So I'm going to uncheck this, because if I were to leave stock to leave on, I'm going to get a different size channel because it's going to leave 0.5 millimeters on both sides, which in this case I don't want. So I'm going to uncheck that. Multiple depths is essential. Anytime we are cutting down with the carve, we don't want to cut it all at once. There are some milling machines that have got very strong bits and very strong spindles, and they can just like sort of mill a lot of it at the same time, maybe all of it at the same time. But for us, we need to kind of do it little bit by little bit. So we want multiple depths, and the maximum roughing step, 10 millimeters, is definitely too much. We want to use a value of 1 millimeter, and this kind of like matches that plunge depth that we had set something similar to in the tool just a moment ago. Okay, and if we switch to our last tab, in this case, I don't think we need to do anything with linking or ramping. We can just hit the OK button, and it's going to take a moment to generate the toolpath. It's going to fill that up. You can sort of see it's showing the toolpath here, where the actual milling head is going, shown in yellow, as well as like these patterns in blue, showing the bit kind of spinning, just sort of bumping around in little circles here. And if we want to try simulating this, which we should, we can click the simulate button. This is going to show us what things are going to look like. And so I'll maybe just look at the isometric view here, and I can turn on stock just to sort of see what does it look like before. And if I hit the play button, we can see here that it's going to mill away this material sort of in small circle patterns as it's working its way from one side to the other. And because we chose multiple depths, it's going to come back and it's going to carve again a couple times. I'm actually not sure if it's going to do 2 or 3 passes. I think probably just 2, but we'll find out in a second. Sometimes this preview might seem quite slow. You can hit the pause button and sort of scrub at whatever speed you want just to get a quick look what this milling operation is going to look like. So this one's quite good. We'll hit the close to get back, and we just now have 2 things left to do. We need to cut the outer contour, and we need to cut this inner channel. I would save the contour to last, because this is where we're going to be cutting through the whole material, and there could be a chance that this would get cut fully away from the stock. Now we're going to leave some tabs so that we'll cut it away. Like the worst thing on a CNC operation is for the part to come loose and be able to move around, because then the milling bit will be cutting all sorts of weird things and it'll wreck the part. So typically the cut that's going to be the closest to removing the part from the stock should be the last thing. So we want to deal with this inside channel next. Now for the next one, this is like a full cut through, so we do want to use the contour feature milling operation. So I'm going to click on 2D contour. Now for the tool, you can see it actually still has the tool we were using before, the 2-flute straight end milling bit. And we don't want to change tools. If it's possible, we just want to stick with one tool. Otherwise, we need to be sort of cutting in one part, stopping the machine, switching everything, realigning, and just kind of adds additional points for failure. So we'll leave the tool the same, and we can see that our settings here align with what we had changed before. 12,000 here, 1,016 here, and 304 here. Those are kind of 3 key numbers for us to double check. Now if we switch to geometry, this looks a little bit different than the adaptive, where it's asking us for a contour, which is like a closed loop 2D path, right? So we can pick any of these contours. I'm interested in this lower contour in here to say let's cut down to here. And if there was going to be some material left over in the middle, I would probably want to use tabs so that that material didn't become free and be able to move around. As it turns out in this part, the thickness of the bit will make it so that we basically carve all that inside as we do the contour, right? As it does this one side, it will basically be milling right up to the midpoint, and when it comes down the other side, it will clear the rest of the material away. So we're not so worried about tabs. So we can just choose the geometry, and we're happy with that. We can look at the heights. We've already checked them once. Those look pretty good to me. Move to the 4th tab. And in this one, again, we want to use multiple depths. Otherwise, it's going to try to cut it all at once, as you can sort of see in that right illustration. We can choose multiple depths, and we can see that our maximum roughing step down is 1 millimeter, which is good. We were using that in the other one as well. Stock to leave is off, which is good. And that last tab has things that we probably aren't going to need to change in any of our operations. So we can just hit OK, and we'll see that it will again take a few seconds to generate the toolpath. If we click on it, you can see in here it looks like it's going to repeat probably about 4 times on each side. We can click simulate to see what it's going to do. We zip through, we've seen those 2 sides already. We can see it's going to run back and forth several times in the middle to cut that channel all the way down to the bottom. So we can hit close, and our last operation is going to be one more. It's going to be the 2D contour operation. We've saved this one to last to cut the outside profile. The tool stays the same. For geometry, I'm going to select this bottom contour, say that's what I want to carve out, and tabs is important for us here. Just like it shows in this illustration here, it can create some tabs so that the part will be held together. We won't totally separate it from the stock, and at the very end we can just use like a utility knife or something like that to cut the tabs away, sand them down, and then we'll get that complete part like we need. Now for tab size, I found that a little bit larger than the defaults works well in our router, especially if we're working in MDF, which is super easy to cut and sand. There's no reason not to go a little bit bigger. So I found that a width of 5 millimeters and a height of 1.5 work reasonably well. And if you use the positioning by distance, you can see it just auto places a bunch of tabs in different locations. I've found that changing positioning to at points is a little bit more intuitive for me, and that just lets us go through and add the tabs ourselves, right? And so you can think about where are the places where you think a little bit of extra support would be useful. So I maybe put 2 on that face, and then we can avoid particular locations where you don't want a tab. I suppose maybe the outside might be a little bit easier to sand down. Probably it's about the same, but we want them relatively evenly spaced so that it will support the piece without needing more than is absolutely necessary. We switch to the 3rd tab, is just the heights again. We can look to the side and we can see that everything looks like it's clear. We move to the 4th one for passes. Again, if we were doing something that maybe was 3D and had some maybe more like detail. We may worry about putting in some of these finishing passes options, but for a simple 2.5D shape like this, I'm not really worried about it. I think just sort of the regular defaults have done a pretty good job, but we do need to always make sure we've got multiple depths selected. This is essential, otherwise we'll definitely break the bit. So we want to make sure that that's chosen and that the step down is 1 millimeter. Okay, and stock to leave is off, which again means that we're going to get that accurate size, which is pretty essential. We hit OK. It'll take a second to generate, and then we can go back one more time. You can simulate each of these individual operations, or if you click on the setup and simulate, it gives us that whole full view of all the operations. So we could quickly scrub through. After we do that middle section, we can see it's tracing the outer contours several times. This should be a key check for us, right? If it just runs one time around the outside, that tells us that we forgot to select multiple depths, right? Because it's always going to take our bit several times to work down to the final depth, even on a thin piece of MDF like 1/4 inch stock. So we hit close, and at this point, definitely want to save because we've got our cam operations are done, and everything's positioned well on the board. We're basically ready to generate the file and run it. Now I want you to be able to save this file because you'll be handing this in so I can double check everything, because there's a risk of damaging the router if we were to run a file that had some problems if you were not careful and you missed one of these steps. So I'll be double checking from this file, but I'd also like you to create the G-code yourself, and the way we do that is we choose the setup, which includes our operations, and we choose post process. And here basically there's something called a post processor, which is written for every specific CNC router, right? There are some differences about how they interpret G-code. So post processor takes a cam file and it generates code specific to that machine. Now I've switched back to the original folder with this basically all the built-in post processors, and these are a whole bunch of different brands for machines that mill things, and none of these are really the one that we want, right? We're looking for a carve, which is made by Inventables. Now they've given us a post processor that I've downloaded, and this will be provided for you. If I change the location, I'm going to put in, this is where I've stored the post processor file. It's a .cps file, and if I look in this drop down, it should take a second to sort of rescan that folder, and you can see in this folder there's only one post processor, and it's the easel post processor. So I'm going to choose that, and then I just have to tell it where am I going to put the file. So I'll maybe put it in the same place in my cam folder, and then I'm going to give it a name. I'm just going to maybe call this cam demo, and those are all the fields that we need to deal with when we hit post. It's going to take a second to first confirm where we're saving this. So this is where I'd said in my M drive, cam demo. It takes a second to generate the file, and once it's done, it should open up this editor. There was actually a checkbox that we could uncheck to say I don't really want to look at it in the editor, but it will show us this file, which we can import directly into easel. I'll maybe show you that for the last step. If we were logged into easel, which I am here, if we went import G-code, we'd have to find that particular file, which I know is in here. We call that cam demo. It's going to take a second to validate the file, and then it's going to show us a preview of what's going on. We'd be starting at that home location, and if I hit play here, put it at 32 times, it's going to show us should be a very similar simulation to what we saw in Inventor HSM. Right, we can see right now it is running 2 passes through those channels, and it doesn't really show us the full preview of where the stock is. It just shows kind of up to the end of where it's carving, which we can see is the 11-inch mark. There is really 1 more inch of stock on this side, and we've got maybe about another 1/2 inch of stock up on this side. And if we look at this in profile, we can see that there were a number of depths. It looks like 6 different depths on the way down, and we can see where the tab would be left in some of those different locations. And at this point, we would be ready to carve. I'd review your file and this G-code, run the simulations just to make sure that everything's looking good, and then we'd be able to set up the router, put in the stock, and carve away.